Alright, part 2 of 1.7 then is going to be about what are called composite functions, and we'll talk about the domain then of those composite functions, how we find that domain, and finally we'll look at a graph and how to read that graph based off of what our composite functions are. So first thing that we have with composite functions, they are inserting one function into another, so you're changing all x's to the second function, meaning we're not plugging in one value for x, we're plugging in a whole long function, and it's represented by this, and we read it f of g of x, and what that means is we're plugging in g of x, so we're taking x, plugging it into g, taking g, that whole function, and plugging it into f. What that would look like then, if we have f of x is 3x minus 4, g of x is x squared minus 2x plus 6. Again, remember this means that you're taking g of x and plugging it into f. So I'm going to take this whole thing here, and there's only one x, so I'm going to plug it in right there. So I'm going to have 3 and then x squared, and I should have equals here, minus 2x plus 6, and then our minus 4 as well. So I'm going to distribute that 3, so I get 3x squared minus 6x plus 18 minus 4, and after I combine like functions, I get 3x squared minus 6x plus 14. Okay, and that would be f of g of x. Now we can also go the other way, so here this is g of f of x, which means that f of x is being plugged in to g. Okay, and you'll notice that in g of x there are two x's. So this whole piece needs to get plugged into both of those x's. And what that will look like when we start, we're going to put it all in parentheses, 3x minus 4 squared minus 2 times 3x minus 4 plus 6. So you see I just changed the x's to 3x minus 4. And now we can't be lazy here. We are going to need to FOIL. So there's a fair amount of work to do on this one. 3x minus 4 squared, remember, means 3x minus 4 times 3x minus 4. If we FOIL that, we're going to get 9x squared minus 24x plus 16. And I'm going to distribute the negative 2 here, so minus 6x plus 8 plus 6. And simplifying things, 9x squared minus 30x plus, looks like 30. 16, 8, and 6 is 30. Yep. And so that would be g of f of x. Okay, we need to remember to take one function, plug it into the other. When we talk about domain of the composite functions, we need to first look and make sure that x is in the domain of g, meaning we're going to look at that interior function first, find its domain restrictions. Then we need to take those domain restrictions or find out for what g, what problems that would create in f. So we need to know the domain restrictions of both. The interior one is going to affect the exterior one. If I look at this now, okay, I know that on my g of x, x cannot be 0. I know if I look at my f of x, x cannot be 1. Okay, so if I'm doing f of g of x, I'm going to have 2 over 3 over x minus 1. Okay, so here, first of all, we had two pieces for our domains on part A. We already know that x cannot be 0 because that would create this piece being a division by 0, which we can't do. Now, for the second part, so for the first part we said, okay, x can't be 0 because of g of x. For the second part, we need to say 3 over x minus 1 can also not equal 0. Okay, so we need to now solve this. So we take our composite function and look at that. 3 over x then equals 1, and that tells us 3 over x equals 1 when x equals 3, which means our domain is x cannot be 0 or 3. So this is where it can be a little tricky. Even though we said x can't be 1 for f of x, in this composite function, x can still be 1, because if we plug in 1, we're no longer getting 0 in the denominator here because we changed our denominator. Okay, so we need to look at our interior function, find that domain first, which is why we have x can't be 0. Then look at the whole composite function and find out what are the domain restrictions of that. Okay, things will change when I look at part B here now, because f is being plugged into g. So I'm going to have 3 over 2 over x minus 1. Okay, so again, if I look at my f piece, x cannot be 1. So I know that's true. Now the second part I need to say is when is 2 over x minus 1 equal to 0? Because we can't have a division by 0. And in this case, there won't be any values of x we could plug in here that will create a whole fraction being 0. So the only domain restriction on that second part is that x cannot be 1. Okay, so last piece then I said we'd look at some graphs for f of g of x. Now it's really important that you pay attention to the order. So we are saying f of g of negative 1. So first thing we need to do is find g of negative 1. So if I go to negative 1 and g, I'm right here, which is negative 3. Which means what I'm asking then is what is f of negative 3. So if I go to negative 3, I'm actually here at 1. So f of g of negative 1 equals 1. Okay, the second piece again, here I'm looking at f of g, so I'm going to start with my g of x, because really this is asking what is f of g of 1, meaning g of 1 is going to be at negative 5, so I'm asking what is f of negative 5. If I go to negative 5, f of x is right there at 3, so f of g of 1 is 3. It changes order, it changes what we're going to look at first. So f of 0, we need to go to where when x is 0, we're going to have it at 2. So now I'm looking for g of 2. So I'm doing it opposite. I looked at red for the first two, now I'm looking at blue. And so g of 2 is going to be at negative 7. Okay, again, last one here, f of negative 1. So I'm going to go to where x is negative 1. Get rid of all those other pieces first. Where f is negative 1, so x is negative 1, f of x is going to be at 1. So I'm saying what is g of 1? And g of 1 is negative 3. Okay, so it's really important that we pay attention to the order of our functions. Okay, that is it for part 2 on 1.7. So we did composite functions, domain. So there was 2 steps to your domain. Now remember, you look at your interior function first, find its domain restrictions. Then you're going to look at your entire composite function, find its domain restrictions. All right, we'll see you next time.